This is lesson 11.2, and in this lesson we'll be talking about congruence tests for triangles. We're going to look at three postulates, and so we talked last time about how postulates are foundational building blocks. They are true. We accept them as truth. Nobody's ever been able to show differently, and so everything is based on that. So postulates, we just have to understand this is the truth, okay? So we're going to look at three postulates that prove that two triangles are congruent without using all six parts, without using all three angles and all three sides, because using 6 parts, if it's not necessary, it's just extra work. So we learned some ways to show that two triangles are congruent using less than 3 parts. These three postulates are what we call congruence tests. There's a total of 5 congruence tests. We're going to talk about 3 of them today, and they're all 3 postulates. Okay, the first postulate is called the SSS postulate. The SSS stands for side, side, side. And the side, side, side postulate, it says, notice that it's a conditional statement. If 3 sides of one triangle are congruent to 3 sides of another triangle, then, so here's the conclusion, the triangles are congruent. So the condition that has to be met is that 3 sides of one triangle have to be congruent to 3 sides of another triangle. And if that happens, then that's enough to prove that the triangles are congruent. You don't need to know about the angles in the triangle. It's enough. I've got a couple of links here to demonstrate that idea, and so I'll show you one of them. But it's good to just kind of explore and satisfy your own mind that that's really true. But if you look at this picture right here, we see that these 2 sides are congruent, and that's because of that marking that's there. These 2 sides are congruent because of the marking, and then these 2 sides also. These happen to be oriented the same way, but if I took this triangle and rotated it that way, it would still be the same triangle. They would still be congruent, so it wouldn't matter. This is the visualization for side, side, side. So if you look at my triangle on the left, I've got my markings on the 3 sides, and then over here, this is exactly the same. So if I drag points and make different side lengths, there's no other way for my triangle on the right to be a different triangle. If you think about it like 3 sticks, if you put them together to a triangle, there's only one way that can happen. And so if I just change the lengths of the sides, there's no way for that to be a different triangle. The second postulate is called the SAS postulate, side, angle, side. The part that's really important about this one is that the angle is in between the 2 sides, and so it's what we call included. So if you think about when you're hanging out with your friends, so if you're, hanging out with a couple of your friends and you're walking along, and if this is your friend and this is your friend and this is you, if you're like this, like you feel included. However, you've probably all been in the situation, I know I have, where there's your friends and they're together, and then there's you, and you do not feel included, do you? You feel kind of left out. And so think about that when we talk about an included angle. The angle has to be inside the 2 sides, so it has to be included within that. So the hypothesis says if 2 sides and the included angle of a triangle are congruent to 2 sides and the included angle of another triangle, that's the hypothesis. If that's true, then the 2 triangles are congruent. So what that means, if we look at a picture, we've got this triangle. This side is congruent to that side, and this side is congruent to that side. The angle that's in between them, that's the included angle, and the way it's marked, these two angles are congruent. So that's a side, an angle, and a side. And so with that, that's enough to prove that those 2 triangles are congruent. And I'll show you again this link right here. I'll show you that in just a second. But it is true, and that's enough. Even if this triangle was rotated, it would not matter. Even if it was reflected, it wouldn't matter. It's still the same triangle. The sides would still correspond to the same side. So we'll look at an example of that. This is the visualization for side, angle, side. So you'll notice in my triangles, the blue, that's my side, and then this angle and the side. So no matter what I do, dragging my orange dot, the 2 triangles will remain the same as far as those angles and those sides. So if I make this triangle have longer sides, the other one has to match. And so you see that there's no other way for the second triangle, this one on the right, there's no other way for that to be a different triangle if that side and angle inside is staying the same between the two triangles. Okay, the third postulate is called the ASA postulate, and that stands for angle, side, angle. So just like last time with the side, angle, side, and the angle had to be included, this time it's the side that has to be included. So you're going to have two angles and the included side. So let's look at the conditional statement. If two angles and the included side of a triangle are congruent to two sides and the included side of another triangle, so notice included side, then the two triangles are congruent. So looking at a picture of that, we see an angle, we see another angle, and then we see an included side. If we looked at a different side, like if we said this one, that's not the same thing. That's two sides and then an angle. Going back to the side, angle, side postulate, if we had, two sides and then the angle was somewhere else, so if it wasn't that one but it was over here, then that angle's not included. And we'll talk about that in just a second. So again, I'm going to show you that visualization real quick, but the angle, side, angle postulate. So far what we've got is we've got side, 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 and angle, side, angle. Okay, and those are the three postulates that will give us a congruence. The other two, I mentioned that there were 5, and we're going to learn the other 2 later, but the other 2 are theorems, so they can be proven. But these 3 are factual. This is the visualization for angle, side, angle. So if you look at this triangle on the left, I've got this angle is fixed and this angle is fixed in this side. So no matter what I do, this triangle will have a matching angle and angle inside. And so if I change this one, that doesn't change anything about the side, but it does change the angles, but they have to change at the same time in the other triangle. So no matter how I change this, there's no other way to have this angle, this side, and this angle, and have in be somewhere else. If you think about it, like if I put this in like over here, that's gonna, if I connect it, that's gonna change this angle, and it's gonna change that angle. So it can't have the 2 angles with the side being the same if the triangles are not gonna be congruent. Okay, the question that everybody wants to ask is, why doesn't this work? Why can't you have 2 sides and an angle that's not included? Because if you've got your side, 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 your side, your angle, side, angle, why doesn't it work? Well, first, and the reason that I'm most grateful for is because if it did, it could spell a bad word all over your homework. And so I'm really glad that that is not the case. However, that's not really the reason why, but just one I'm glad for. But anyway, why doesn't that work? So if we look at this, that's going to show you why that can't work. It's not enough to show congruence. If you have 2 sides and then an angle that's not included, it's just not enough to prove that it's congruent. This is the visualization for why side, side, angle does not work. So here on the left, I have this triangle ABC, and you'll notice that side CB and side BA, those are my 2 sides, and then angle A is the angle. So if I was to take the triangle, like you can see, if I can have congruent triangles, like it's possible, but if you keep the same side and side, you are able to have a different triangle with that exact same thing. And that's why side, side, angle does not work, because you can't keep the same 2 sides with this angle over here and always have congruent triangles like we saw with the other tests. This lesson will be continued in the next video.